Hello students, today we are going to discuss some important questions and answers on group 17 and group 18 elements. So let's get started. The first question is, although electron gain enthalpy of fluorine is less negative as compared to chlorine, but fluorine is a stronger oxidizing agent than chlorine. Why? So this is the question. So first of all, we have already discussed that fluorine and chlorine have the electron gain enthalpy values like fluorine has the electron gain enthalpy minus 333 kilojoule per mole and chlorine has the value minus 348 kilojoule per mole. Now, among these two datas, we can see that chlorine has the higher electron gain enthalpy value than fluorine, which indicates chlorine is accepting the electron and converting into Cl minus more easily than fluorine, correct? Now, let's come to the concept of oxidizing agent. Who is oxidizing agent? Oxidizing agent is that substance or that species that easily accepts electron and convert into the corresponding product, and that means oxidizing agent is that substance that accepts electron and reduce itself, correct? Now from the data of electron gain enthalpy values, it's clear that chlorine is accepting electron and converting into Cl minus more easily or more spontaneously than fluorine. So that, and that for this reason, it is indicating that chlorine should be more oxidizing, or chlorine should behave like a better oxidizing agent than fluorine, because oxidizing agent is that substance that accepts electron easily. Chlorine is accepting electron easily, that is indicated by electron gain enthalpy value, correct? Our general expectation is that chlorine should be better oxidizing agent than fluorine, but in reality fluorine is a better oxidizing agent than chlorine, right? Now, as we have already discussed, that oxidizing agent is that substance that accepts electron spontaneously and reduce itself. So let's discuss the process of accepting electron for fluorine and chlorine by the following way, correct? Now the process of accepting electron for fluorine and chlorine is actually uh, is consist of the process of accepting electron fluorine and chlorine consists of three steps. Okay, in the first step, the molecule fluorine and chlorine is dissociating to give fluorine gas, fluorine atom, single atom of fluorine and chlorine. Okay, in the second step, the fluorine is accepting electron uh, and converting into F minus, and Cl is accepting electron and converting into Cl minus. Okay, the energy involved are electron gain enthalpy, delta H Eg for fluorine, and this is the delta H Eg for chlorine. Okay, here enthalpy of dissociation is involved in the process of dissociating the fluorine molecule to produce the fluorine atom. Here also enthalpy of dissociation is involved in the process of converting Cl2 into chlorine atom. Now in the third step, F minus will be hydrated in presence of water, and it is termed as F minus aqueous. Similarly, Cl minus will be hydrated to produce Cl minus aqueous, and the energy involved are enthalpy of hydration for F minus and enthalpy of hydration for Cl minus. So these are the three steps in which fluorine is accepting electron. Okay, now let's discuss the steps one by one and compare the relative spontaneity of the steps for fluorine and chlorine. So let's discuss with the first step. So in the first step, fluorine molecule that consists of two fluorine atom is dissociating to form fluorine gas or fluorine atom. Similarly, chlorine molecule is dissociating to give chlorine atom. Okay, now for this reason you have to give energy. That's why enthalpy of dissociation that is involved is positive, delta H dissociation. Here also delta H dissociation is positive. You have to give energy to dissociate the fluorine molecule or chlorine molecule. Now if we look on the fluorine molecule, as we know fluorine is the smallest size atom, so this fluorine bond is very much short bond, right? So since the fluorine bond is very much short, then obviously we can expect that there will be highest repulsion between the lone pairs of fluorine atoms, which lead to weakening of the fluorine fluorine bond. That means whenever repulsion will be highest between the lone pairs of fluorine atoms, this fluorine fluorine bond will be cleaved easily, right? Less energy is required to cleave or to break this bond, right? Because of the presence of the repulsion, fluorine molecule will try to avoid this repulsion, right? So we have to give very much less amount of energy to break this fluorine fluorine bond, right? So enthalpy of dissociation, that means delta H this enthalpy of dissociation is very much less in fluorine in comparison to chlorine. That means the process of dissociation from F2 to produce F atom is very much spontaneous for fluorine, because very much less amount of energy is needed to dissociate the fluorine molecule. If less energy is needed to dissociate a molecule, obviously the process will be very fast, right? So the step 1 for fluorine is much more spontaneous than step 1 of chlorine, correct? Now let's discuss the uh, second step. Okay, so in the second step, fluorine and chlorine atom are accepting one electron and converting into F minus and Cl minus. So obviously in this process, who will be involved in this process? Enthalpy of electron gain enthalpy will be involved. And as we have already discussed, electron gain enthalpy of chlorine is much higher than electron gain enthalpy of fluorine. That means the process of accepting electron in case of chlorine is much more spontaneous process than process of accepting electron in case of fluorine. That means this second step is much more spontaneous for chlorine than fluorine. That means step 2 is more spontaneous for chlorine than fluorine. So far we have discussed two things, the step 1 and step 2. So step 1 is more spontaneous for fluorine, step 2 is more spontaneous for chlorine. Now let's go move on to the third step. In the third step, F minus is hydrated and Cl minus is hydrated to form F minus aqueous and Cl minus aqueous. Now we have already discussed that F minus will be the smallest size atom, right? If the size of fluorine atom is the smallest among all the element in the periodic table, so F minus will have the smallest size, right? And since F minus has the smallest size, we can expect the charge density in F minus is highest, correct? The charge density in F minus is highest because F minus has the smallest size, correct? So since the charge density of F minus is highest, if whenever F minus will be hydrated, high amount of energy will be released in case of hydration of F minus. If F minus has the highest charge density, and that's why more amount of water molecules will hydrate the F minus, and that's why high amount of energy will be released in the process of hydration of F minus. And that for this reason the process of conversion and for this reason the F minus aqueous, this species, will be very much stable because high amount of energy will be released in this process in the third step. So if high amount of energy is released in the process in the third step, so obviously we can expect that F minus aqueous, this species, will be very much stable. And if this species F minus is very much stable, then we can expect the third step is much more spontaneous than the third step, right? So for this reason we can say that third step is much more spontaneous for F minus in comparison to Cl minus. So far we have discussed three steps. Step 1 is more spontaneous for fluorine than chlorine. Step 2 is more spontaneous for chlorine than fluorine. Step 3 is more spontaneous for fluorine than chlorine. So in a total summary, if I tell you the summary of these three steps, spontaneity of this, regarding the spontaneity of these three steps, we can say that for fluorine step 1 and step 3 is spontaneous, and for chlorine only step 2 is spontaneous. So what is our general expectation? For fluorine, two steps are spontaneous in the total process of accepting electron, but for chlorine only one step, that is step number 2, is only spontaneous. So obviously overall, if we think about the overall process of accepting electron, fluorine is much ahead than chlorine, in the process of accepting electron, that we can say that, right? Because for fluorine, two steps, step 1 and step 3 are spontaneous, but for chlorine only step 2 is spontaneous. That means from this overview we can say that a process of accepting electron, overall process of accepting electron for fluorine is spontaneous than chlorine, right? And that means, so till now we have concluded that the process of accepting electron for fluorine is more spontaneous than chlorine, correct? And this data, this information leads to the fact that fluorine is a better oxidizing agent than chlorine, because oxidizing agent is that substance that accepts electron, and we have already discussed, we have already proved that process of accepting electron is more spontaneous in fluorine than chlorine, which leads to the better oxidizing property for fluorine than chlorine. So in spite of having less value of electron gain enthalpy, fluorine act as a better oxidizing agent. What is the reason? The reason is this: because the process of accepting electron, overall if we think of a process of accepting electron, then fluorine will be much ahead than chlorine in the process of accepting electron, which imparts a better oxidizing property for fluorine than chlorine. Okay. Now let's move on to the second question. What is it saying? Fluorine exhibits only one oxidation state, that is -1, whereas other halogens exhibit +1, +3, +5 and +7 uh, oxidation state along with -1. Why? So first of all, fluorine is a member of period number 2. It has only 2s and 2p orbital in its valence shell. In fact, fluorine has the valence shell configuration 2s to 2p5. So only 2s and 2p orbitals are there in the valence shell of fluorine. It has no d orbital. Since it has no d orbital, it cannot expand its octet and cannot exhibit different higher oxidation state like +3, +5 and +7, right? Moreover, fluorine is the most electronegative element present in the periodic table. That's why fluorine cannot exhibit positive oxidation state. Rather, fluorine only exhibits one oxidation state, and that is only -1. Okay, so for the non-availability of d orbitals and also being the most electronegative element in the periodic table, fluorine cannot exhibit positive oxidation states or higher oxidation states in its compounds. Only -1 oxidation state is shown by fluorine atom. Now let's move on to the third question: why noble gases have very low boiling points? So as we know, for exhibiting higher boiling point, the molecules or the elements have to be bounded by strong forces, right? If they are bound by strong forces, then only they can exhibit higher boiling point. But as far the noble gas atoms are concerned, they are monoatomic in nature, and they have completely filled cell in their valence shell. And since they have the completely filled cell in their valence shell, they have no tendency to bind with one another. And moreover, we can say that they have no interatomic forces that can bind them together. They are only bound by weak van der Waals force, and that is a very weak force, and that's why the binding process, the binding of the noble gas elements is very much low, which demands very low boiling point, which demands a very less amount of energy to boil the noble gas elements, right? So for this reason, noble gases have very low boiling point. This is because of the completely filled cell, and that's why they are not at all bound by interatomic forces. Only weak van der Waals force is responsible for binding them together, and van der Waals force is a weak force, and that's why the boiling point for noble gases is very much less. Okay, now let's move on to the question number 4. Why noble gases have very high ionization enthalpy? So obviously it is a replicate question, you can say replicate question of question number 3, because noble gases, as we have already discussed, the noble gases have completely filled cell. They have the general electronic configuration ns2 np6, right? So the orbitals are completely filled, and that's why it's very difficult to take out one electron from this completely filled state, from this very stable completely filled orbital, and that's why high amount of energy is required to remove electron from their valence shells or from their valence orbitals, and which demands very high amount of very high ionization enthalpy. Okay, and for the and since they have very high ionization enthalpy, they only react with some few elements in certain under certain condition to give some products. Okay, so this is the reason why noble gases have very high ionization enthalpy. So this is all about some important question uh, for this group 17 and group 18 elements. Hope you have understood all the topics. Thank you for watching this video. See you in the next class. Thank you.